Hi TF, Monica here. Can you please assist with this question?
Let's jump right into it and see how do you actually work with functions sketched on the same set of axes in this case. Right, so the question says to us here in the diagram below, A and B are the x-intercepts of the graph of f of x equals x squared minus 2x minus 3. A straight line G cuts f at a point C with the coordinates 4:5. So this is going to be the point 4:5, right? And the y-axis at the point 0:1. So we can clearly see this. M is a point on F and N is a point on G such that MN is parallel. MN is parallel to the y-axis. We can clearly see that. Quite awesome stuff. MN cuts the x-axis at point T. Right, so what's the story here? Show that g of x is equal to x plus 1. Show that g of x is equals to x plus 1. Right. So what we need to do here is acknowledge the fact that g of x is a straight line. And we know for a fact that this is the y-intercept of the line. Right. And the y-intercept is always your c value when you are using y is equal to mx plus c. Right. So I can just simply go and say y is mx plus c. My c value there is simply a value of 1 because we are told that it's passing at point 1. And then I'm going to look for any point that the line passes through. In this case, I'll take the coordinates of c, which is 4, as well as 5. Right, so my y value is 5. The gradient is unknown, but the x value is 4 plus 1. And then we just simply try to simplify this. Take 1 to the left. 5 minus 1 gives us 4. Is m into 4, and then eventually your gradient comes out as 1. Therefore, the graph of g of x is 1x plus 1. Absolutely easy and simple. You don't need to write that one. You can put it if you want to write it. Okay, let's move on to the next question. The next question says to us, we need to calculate the coordinates of A and B. Oh, awesome. A and B are simply the x-intercepts of this particular graph. So we know for a fact that we don't know what x is, but y is definitely 0. Even at point A, the same story is the case. We don't know what x is, but we know for a fact that the y value is 0. So if you want to find out the coordinates of A as well as B, just simply take the equation of the graph of f of x, and then wherever you see y, substitute it with 0. According to what we saw in the opening statement, the graph is given by x squared minus, is it 3x or 2x? Let's check it and be certain. There it is, minus 2x minus 3, right? Minus 2x minus 3, right? Minus 2x minus 3. So our y is going to be 0, right? So you're going to have x squared minus 2x minus 3, and then you try to solve for x here by factorization. You can use the quadratic formula, Monica, or you can just simply factorize. Find the factors of x squared, x and x. You've got 3 and 1 here. The bigger number takes the sign of the middle term. Therefore, x is going to come out as 3, or x will come out as negative 1. And according to the drawing, you can clearly see that A is on the negative x-axis, so it has to take the negative x value, and B is on the positive x-axis. It would have to take the positive value of 3. Then the coordinates of A will just be minus 1 is to 0, and then B will just simply be 3 is to 0. Quite powerful and not complicated at all. All right, now let's go to the last part of this question. We are now required to find the range of the graph of f. Now the range is simply speaking to us about the y values that the graph covers. All the y values that the graph does actually cover. You will not be able to find the range of the graph without finding the turning point there. We need to know what is the minimum value of this graph. What is the minimum value of this graph? Once we know this, we know that the graph starts from that particular value and goes all the way up to infinity. So the interest here is just on finding the corresponding y coordinate of the turning point. Once we know that, then we will be able to provide the solution for the range of this question. All right, now I'm going to use a different technique of finding the x-coordinate of the turning point. Remember, guys, you can always say the x-coordinate of the turning point is minus b over 2a. That is highly acceptable. Or you can actually use what I'm about to use now. The x-coordinate of the TP is the sum of the x-intercepts divided by 2, the average of the x-intercept. Remember, at point A, we had an x value of minus 1. We found minus 1 here. We found 3 at B. So when you add those two and you divide them by 2, you're going to get 3 minus 1, which is 2 over 2. And that's going to give you an x value of 1 at the turning point. So our turning point has an x value of 1. We are looking now for the corresponding y value of the turning point. So in order to find the corresponding y value of the turning point, just substitute this x wherever you see y on the original equation of the graph. So y is going to be, it was x squared minus 2 into x minus 3, and then if you simplify this, you're going to get a y value of negative 4. So your coordinates of the turning point are 1 is to minus 4. Therefore, to conclude, your range will just simply be, the range is y is the element of, you have to include the turning point because the graph does reach the turning point and then it goes all the way to infinity.